Today we will be discussing about some of the uses of hydrogen for cutting and welding metals. When a mixture of hydrogen and oxygen is burnt, it gives a very hot flame. This flame is known as oxyhydrogen flame and it is used for cutting and welding of metals. Liquid hydrogen is used as a fuel in rockets and guided missiles. For the hydrogenation of vegetable oil. We all know vegetable oil is liquid at room temperature. Hydrogenation is a process in which this liquid oil is converted into solid vegetable ghee on treating with hydrogen in the presence of nickel as a catalyst. So the liquid vegetable oil is converted into solid vegetable ghee. Examples are margarine, the dalda that we use at home. Hydrogen is used in the manufacture of different chemicals. In the manufacture of ammonia, hydrogen is used in the Haber's process. Hydrogen is also used to prepare methane, that is CH4. Hydrogen is also used in the manufacture of the very common acid, hydrochloric acid, HCl. Hydrogen can be used as an alternative source of energy. Hydrogen is seen as a fuel or as an alternative source of energy for the future in industry and automobiles. Since it forms water rather than harmful gases on burning, it is seen as a clean fuel of the future. So when hydrogen burns, it produces water. It does not produce any harmful gas. So it can be used as a fuel in automobiles without creating any air pollution. Now let's discuss about oxidation reduction reactions, also known as redox reactions. A chemical process that involves the addition of oxygen or the removal of hydrogen is called oxidation. So addition of oxygen or removal of hydrogen is called oxidation reaction. Let's see an example. Magnesium plus oxygen gives out magnesium oxide. So what is being added to magnesium? Oxygen to form magnesium oxide. So it is an example of an oxidation reaction. The next one, hydrogen sulfide plus chlorine gives out hydrochloric acid and sulfur. Now see here, hydrogen is being removed from sulfur. Hydrogen is being removed from sulfur. So this is also an oxidation reaction in which hydrogen is being removed. So hydrogen is being removed from sulfur. So it is an oxidation reaction. Now reduction. Reduction is just the reverse or opposite of oxidation. A chemical process that involves the addition of hydrogen or the removal of oxygen is called reduction. So in reduction there is addition of hydrogen or removal of oxygen, whereas in oxidation it was addition of oxygen or removal of hydrogen. So it is just the opposite. So let's see an example of reduction. Copper oxide plus hydrogen gives out copper plus water. Now see here, copper oxide CuO and what has been formed? Cu, copper. So here there is reduction because oxygen has been removed. Okay, and the next one, addition of hydrogen. Hydrogen plus chlorine gives out hydrogen chloride. Here In chlorine, hydrogen has been added, so it is a reduction reaction. So if oxygen is removed or hydrogen is added, then we count it as a reduction reaction. Now we come to redox reaction from reduction and oxidation. So redox comes from two words, reduction and oxidation. A redox reaction is a reaction in which oxidation and reduction occur simultaneously. That means they occur together. A substance that helps in oxidation or brings about oxidation is called an oxidizing agent, and a substance that brings about reduction is called a reducing agent. Examples of oxidizing agents are oxygen, ozone, chlorine, bromine, potassium permanganate, sulfuric acid, nitric acid, hydrogen peroxide. And examples of reducing agents are hydrogen, hydrogen sulfide, carbon, sulfur dioxide, etc. So, hydrogen is a reducing agent. Now, let's see an example of a redox reaction or a reaction in which oxidation and reduction occur simultaneously. The reaction between copper oxide and hydrogen. CuO plus H2 gives out Cu plus H2O. Copper oxide is reduced to form copper. CuO forms Cu. That means oxygen has been removed from copper oxide. So here reduction takes place. Whereas hydrogen H2 forms H2O. Oxygen has been added to hydrogen. So here oxidation takes place. So in copper oxide there is removal of oxygen resulting in reduction, and in hydrogen there is addition of oxygen resulting in oxidation. So both reduction and oxidation are taking place simultaneously, so it is an example of a redox reaction. So, in this reaction, the substance that has been oxidized is hydrogen. And what is the oxidizing agent? Copper oxide, because oxygen is coming from copper oxide. The substance reduced is copper oxide, and what is the reducing agent? Hydrogen, because the oxygen from copper oxide has been taken by hydrogen. So here the oxidizing agent is copper oxide and the reducing agent is hydrogen. So the substance that aids in oxidation is known as oxidizing agent, and the substance that aids in reduction is known as reducing agent. Let's see another example of a redox reaction. Chlorine plus hydrogen sulfide gives out hydrogen chloride plus sulfur. Cl2 plus H2S gives out HCl plus S. Now see here, Cl2 is forming HCl. That means what is being added? Hydrogen is being added to chlorine. So addition of hydrogen leads to reduction. So there is reduction of chlorine. And H2S forms S. That means hydrogen is being removed from sulfur. So removal of hydrogen leads to oxidation. So chlorine is reduced whereas sulfur is oxidized. So it is a redox reaction. So the substance oxidized is hydrogen sulfide, and that is H2S. And what is the oxidizing agent? Chlorine, because chlorine is taking away the hydrogen. And substance reduced is chlorine. And what is the reducing agent? H2S, because hydrogen is being got from H2S. So the substance oxidized is H2S and the substance reduced is chlorine. So addition of hydrogen is oxidation and removal of hydrogen is oxidation. And who is aiding in the helping of oxidation? Chlorine. And who is helping in the reduction? Hydrogen sulfide. So this is another example of a redox reaction. So reduction and oxidation take place simultaneously, and hence it is known as a redox reaction. The today we did uses of hydrogen and oxidation and reduction reactions along with redox reactions. Thank you everyone.